Hello, children. How are you all? I hope you all are fine and keeping yourself safe. Dear children, I got a surprise for you all. Are you excited to know that? I know you are. So, I am planning to take you for a picnic. Now, wondering that where and how we will go to a picnic? So, yes, I have an answer for that. But before that, I want to ask you something. That are you not missing your friends? Are you not missing eating, chatting, playing, dancing, and so many other things, even teasing to them? I know you all must be missing them. As being a teacher, I also am missing you people. So, I thought to take you all to a picnic. And where we will go to that picnic? Hmm? Like nowadays everything is happening online, so I thought that I would take you picnic online only. And that picnic we are going to North America. Okay, so today we will talk about North America. This is one of the continents, and in this video we will learn more about that. Okay, so let's start. North America, the third largest continent of the world, is remarkable in many ways. From the world's greatest inland water body, the Great Lakes, to the world's tallest trees, the giant redwood trees, and some large animals, moose, bison, and grizzly bear, to name a few. North America holds a host of natural wonders of the world. It is also a land of spectacular geographical features such as the Grand Canyon, Niagara Falls, Old Faithful Geyser, and granite cliffs of Yosemite. Early humans most likely walked into this land across a land bridge created between Asia and today's Alaska during the last glacial age. Now let's have a brief idea of the formation of continents. It is believed that continents and oceans were formed millions of years ago. The seven continents as they appear today were joined together in one huge continental mass or supercontinent called Pangea. The Pangea was surrounded by a large mass of water or universal ocean known as Panthalassa. Now this all bluish part is Panthalassa. This all bluish part, and this all yellowish part is Pangea. This was supposed to be the combination of all the continents in a huge landmass. Now the Pangea that you are seeing in the picture is considered that it was like this 225 million years ago. Now the picture that you are seeing on the screen, this is of Pangea when it broke up and land masses split and moved away. Earlier it was a single huge landmass in which all the continents were there, but then when it broke up it split into two huge landmasses which were Laurasia and Gondwana land. Now what happened next when Pangea broke into two huge landmasses, Laurasia and Gondwana? Did they break down further or did they remain like that? We will talk about that, but before that let's discuss about the seven continents of the world. First is North Africa, North America, second South America, now this is Africa, Europe, Asia, Australia and Antarctica. Now this picture that you are seeing on the screen is the present position of the continents that is likely to change in 100 million years. Now continents that we just talked about are clearly visible here, like first North America, South America, Africa, Europe, Asia, Australia and Antarctica. Now, when Pangea broke into two huge land masses called Laurasia and Gondwana land, then those two huge land masses divided or split into these seven continents, and this is the actual position of the continents at the present time. The heat of the Earth's interior that gives rise to convection currents must have contributed towards the breaking up of the Pangea along lines of weaknesses. The Earth's crust, which is like a hard eggshell, broke up into several large as well as small tectonic plates. Now observe the picture of a cracked eggshell given here. Each piece of the broken shell, like this piece, then this, then this, then this, then this, then this, all these pieces. So each of these pieces of broken eggshell is like a tectonic plate. The cracks on the eggshell are like boundaries of the tectonic plates. These tectonic plates float on the partially molten part of the interior of the Earth. Driven by the convection currents, the plates move slowly but steadily. Initially, Pangea broke up into two large continents, Laurasia and Gondwana land. Laurasia forms the major part of North America, while South America is a part of the Gondwana land. In the early part of the 20th century, the German geophysicist Alfred Wegener explained the continental drift theory. In other words, he spoke of how the continents drifted to where they stand today. Convection is the tendency of hotter and less dense material to rise and colder material to sink, causes movement within a fluid that is called convection. Then tectonic, its meaning is relating to the structure and movement of the surface of the earth. The parts of Gondwana land that contain Africa and South America form an ideal jigsaw fit. This, along with several other evidences, makes us believe that the drifting of continents did take place. Now here in this picture only, these parts are continental shelf. Now here you can see that these parts arrowing this side are the regions of overlap. These arrows are showing us continental shelf, that including the continental shelf improves the overall fit aside from a few small areas of overlap. Further, we will talk about convergent and divergent movements. The movements of the Earth's plates are mainly either convergent or divergent. Now, let us talk about these movements. This will help us in understanding that how the continents of North and South America were formed. What are convergent movements? Convergent movement when two plates move towards each other and collide. Like in this picture, one plate is this, another plate is this. So what is happening here in this picture? That it was coming, this plate was coming from this side, it was coming from this side. They met and collided. Now the weaker plate usually slips below the more stable one. So this plate would be the weaker one. That is why it slips towards or below the more stable one. Like this, we can consider this plate, we can consider the more stable one, as it is seen massive and strong. So it was obvious that the weaker plate would have slipped below this plate. Now this is known as subduction. The pressure of plates at the junction is so massive that the rocks can melt and erupt through volcanoes. Now see, this plate came from this way, this plate came from this way. They collided here and they made a pressure. This plate got slipped below this plate, as this one was the massive one and the more stable one. Now the junction where they collided, this pressure is so big and massive that the rocks can melt. Like you can say it is the melted rock here, and it is erupting through the volcano. Now see, in this picture, this is the melted rocks. Now, it got melted due to the pressure that was built when the two plates collided together. Now this melted rock is erupting through this volcano, right? Now the occurrence of earthquakes is common too. The fold mountains are formed at this junction of convergent boundaries. For example, in the past, the Nazca Plate and South American Plate collided, and this in turn folded up the Andes Mountains along the western margin of South America. Similarly, the Pacific Ocean Plate subducted below the North American Plate along the Californian coast.
Convergent boundaries occur when tectonic plates move towards each other and strike one another. If you look at this map of the major plates, you can notice several that are convergent boundaries. As these plates move and strike one another, you may get earthquakes, volcanoes, or deep trenches. There are three major types of convergent boundaries: oceanic and continental lithosphere, oceanic and oceanic lithosphere, and continental lithosphere. Oceanic and continental convergent boundaries occur when oceanic crust subducts underneath the continental crust. The oceanic lithosphere has a greater density than the continental lithosphere, and as it collides with the continental crust, it subducts underneath the continental lithosphere. As it sinks, magma is formed and begins to rise to the surface and may form volcanic mountains. Earthquakes may also occur and deep trenches may be formed. An example is when the oceanic Nazca Plate subducts underneath the continental South America Plate. At this location, the Atacama Trench has been formed in the ocean, and the volcanic mountain Lascar is located on the land. When oceanic lithosphere collides with oceanic lithosphere, a similar event occurs. The older oceanic crust is more dense than the younger crust and subducts underneath. As it subducts, magma begins to rise to the surface, and this can create volcanic island arcs. An example is the portion of the North American plate covered with ocean subducts underneath the Pacific Oceanic Plate. The Aleutian Islands have been created from this collision. When continental strikes continental lithosphere, neither crust subducts, nor is magma or earthquakes occur. These 2 graham crackers illustrate what happens. The 2 plates buckle and create folded mountains. An example is the Indian Plate colliding with the Eurasian Plate and creating the Himalayan mountain range.
The picture that you are seeing on the screen is a map of North America showing its political divisions. Now next, this picture that you are seeing is a map of North America showing its physical divisions or physical features. Now let's discuss about divergent movement. This occurs when 2 plates move away from each other, and as a result the ocean floor begins to spread. Often magma may erupt from the interior and create new landforms. For example, the Atlantic Ocean widened in a similar divergent movement, and the Mid-Atlantic Ridge, a continuous mountain chain, formed along the junction of the plates in the ocean. Divergent movement is just opposite to the convergent movement. In convergent movement, the 2 tectonic plates collide because they come closer to one another, but here in divergent, 2 plates just go away from one another. And often what happens, like seen in the picture, this plate is going this way, this plate is going this way, and here it is leaving this space. At times what happens, that magma erupt from the interior, magma will erupt from the interior and it can form a different landmass here.
Now that you know what plate tectonics is and what the structure of the Earth is, we can look at the movement of the plates. Divergent zones are explained in this video. These are zones where the plates move apart. As you have seen in the previous video, the continental crust is much thicker than the oceanic crust. Under a continental crust, the mantle can therefore become very hot, because the mantle cannot lose the heat. The rock expands due to the heat. If the heat makes the rock fluid, it can expand even more. The expanding magma causes the continent to rise. The continent can therefore break due to the pressure. Gravity then ensures that the broken plate will slip. This force is called the ridge push. This is one of the reasons that plates move. A very long crack appears in the crust where the plates move apart. Here material can rise from the mantle and solidify on the surface as basalt. This new crust is deeper than the previous continental crust. As a result, water flows to this low point. If the plates keep moving apart and more oceanic crust is created, an ocean can form. The crack where oceanic crust is made sometimes lies exactly between two continental plates and therefore in the middle of the ocean. Here the ocean is usually about 2,500 meters deep, which is relatively shallow for the ocean. As a result, places where the plates move apart are also called mid-oceanic ridges. Close to the mid-oceanic ridge, the oceanic crust is relatively young and also warm. Over time, the crust moves away from the mid-oceanic ridge. The crust grows older, becomes cooler, which increases the density. This causes the crust to lie deeper, making the ocean 5.5 kilometers deep. The part of the oceanic crust that is further away from the mid-oceanic ridge is already older, which means that more sediment layers have been deposited there. While with the younger crust, closer to the mid-oceanic ridge, fewer sediment layers could be deposited. This is proof that the crust at the mid-oceanic ridge is younger and therefore originated there. Because the plate is stretched at starting divergent zones, it becomes thinner. You can compare this process to stretching an elastic band. Stretching will lower the crust. The low-lying part in the middle of the divergent zone is called a graben. The sides remain relatively high. We call these high-lying parts a horst. This causes some relief in the region. With a divergent movement, basaltic magma emerges. Because basaltic magma is very liquid, shield volcanoes arise in divergent zones. These are volcanoes that are very wide but not very high. That is because the liquid basaltic magma flows away very easily, making the volcano very wide but not high. The volcano eruption is effusive. These are eruptions that go relatively smoothly. So you have learned how a divergent movement arises, what consequences this has for the depth of the ocean, and what type of volcanoes and volcanism can arise there.
Now let's talk about North America. North America was believed to have been discovered by the famous Italian explorer and navigator Christopher Columbus in 1492. He was on the lookout for a sea route to India, and seeing the natives of the new place he had discovered, he mistook it to be India and named it Indies. That is how the Caribbean islands presumably came to be known as West Indies. Later, the continent got its present name after another famous explorer named Amerigo Vespucci, who landed there after a few years of Columbus's first visit. Now, if we talk about the location, North America lies completely in the western and northern hemisphere. It covers an approximate area of 93,55,000 square miles. The continent is separated from Europe by the Atlantic Ocean. The vast Pacific Ocean lies between Asia and North America. The continent lies entirely to the north of the equator. It lies for the most part between the Arctic Circle in the north and the Tropic of Cancer in the south. Now here is given a list of some North American and Caribbean countries and their capitals. Let's read them out. Antigua and Barbuda, capital St. John's. The Commonwealth of the Bahamas, capital Nassau. Barbados, capital Bridgetown. Canada, capital Ottawa. The Republic of Cuba, capital Havana. The Commonwealth of Dominica, capital Rosario. Dominican Republic, capital Santo Domingo de Guzman. Grenada, capital St. George's. The Republic of Haiti, capital Port-au-Prince. Jamaica, capital Kingston. The United Mexican States, capital Mexico City. The Federation of Saint Kitts and Nevis, capital Basseterre. Saint Lucia, capital Castries. Saint Vincent and the Grenadines, capital Kingstown. The United States of America, capital Washington, D.C. Belize, capital Belmopan. The Republic of Costa Rica, capital San Jose. The Republic of El Salvador, capital San Salvador. The Republic of Guatemala, capital Guatemala City. The Republic of Honduras, capital Tegucigalpa. The Republic of Nicaragua, capital Managua. The Republic of Panama, capital Panama City. If we talk about the boundaries, North America is separated from Asia by the narrow Bering Strait in the northwest sea. This is Asia. This is North America, and in between it is a Bering Strait. Strait is a narrow stretch of seawater linking two large water bodies and separating two land masses. Also, North America is linked with South America by the narrow Isthmus of Panama. Here it is. This is North America, this is South America, and this is Isthmus of Panama. The continent is bounded by the Arctic Ocean in the north, the Gulf of Mexico and Caribbean Sea in the south. The Atlantic and Pacific Oceans wash its eastern and western shores respectively. Now, Isthmus is a narrow strip of land with sea on either side, linking two larger land masses. I hope all of you have enjoyed a lot the video and learned a lot from it. Rest of the part we will cover in next video. Till then, I want every one of you to go through and see the video nicely and go through the textbook of yours and study about North America more. Bye bye children, have a great day ahead.